The week after spring break, we are covering Chapter 11. It covers joining multiple tables together. So, multiple tables. We have multiple tables due to data normalization, meaning we need to make sure that data is not duplicated on the hard disk, as discussed in Chapters 1 and 2. And because of that, to get reasonable output for the end user, we have to link data into a report that comes from multiple tables. The best method that we've been using is to use the join clause. It's actually a special type of join called a conditional join within the from statement. This book goes over multiple ways to join tables together, and most of the methods discussed are complex or give an undesirable output, or possibly not implemented in some of the database implementations out there. A comma-separated join is one of the simplest forms of join. You simply type select from and then list tables separated by commas. The output is typically not meaningful to the end user. It produces something called a Cartesian product. Cartesian was a mathematician that simply linked everything from one table to everything in another table. You're basically multiplying rows in one table times the rows in another table. So an example of bogus output. Say there's 22 colleges in the state, and they're listed in one table. You have a second table that has 150 degree programs offered in the state of Arkansas. Those will be offered between the different colleges. Not all colleges offer the same degree program. So if we were to do a Cartesian join, we would get 3,300 rows. The John Deere program is only offered on the ASU BB campus, but the output would match the program with each college in the state, and it would appear that John Deere was offered at all 22 colleges instead of just listing John Deere beside ASU BB. As you see, a Cartesian join does not give any type of output that an end user would like to see. An Equijoin. This is where you add a where statement to a comma-separated join. So now we've created a condition to where that the information in one column in one table must match up to the information in a second column in the second table. That is called an Equijoin. So if we reran the previous query and added a where statement and say where college ID equals college ID in the second table, the output would show only one row for the John Deere program instead of 22, because the John Deere program is only matched with the ID for ASU BB, not the other 21 colleges. So now we actually have some code that would give meaningful output to an end user. Joining tables using where, though, you might have too many ands and ors and confuse your logic. So a better approach is to join the table in the from statement or from clause instead of trying to do it in the where statement. Correlation names. When you join multiple tables together and they have the same name between two tables, the database doesn't know what to do. So, it's like call the police. Well, there's a police department in every town. Which one would you want to call? So you've got to actually specify what to do. So a correlation name here on the second bullet is basically the table name with a period followed by the column name. So you'd know exactly what table to ask for information. You could also abbreviate the table name. We've done this in class where you typed in the table name followed by space and a 1 or 2 letter abbreviation. So as you see some examples, we could do select star from employee with an abbreviation E, and salary S, where S is the abbreviation for salary. And if you look below at the examples, you could either do E.employeeID equals S.employeeID, or if you didn't abbreviate, or even if you did, you can still use the full table name, such as employee.empid or salary.empid. I think in class we decided that abbreviating and typing less was a lot easier. So you should always use correlation names in queries, even if the tables don't match. It's just good coding practice and much easier for other individuals working in your coding team to understand your code. One last note, if the column names are unique between tables, it's not required. But as I just said, for proper coding practice and make it easier, always use correlation names when you're joining multiple tables. A self-join. We showed an example early in the semester where the table joins to itself. So exactly how many tables are used? 1. Why would you want to use this? One of the main examples that we've used is you have employees at the company. Some of them are managers over other employees at the company, but managers, CEOs, janitors, floor workers, everyone is an employee, so they all are contained within the employee table. To figure out who is the boss or supervisor over another employee, you join it back to itself. You typically have one column that denotes the ID of the manager or supervisor. So when you link them to themselves, you can look up the manager ID, look up his name, and display the name of the manager out beside the low-level employees. So that is called a self-join. Before I go any further, I want to show an example of a Cartesian join. So I'll bring up my Chinook database. And let's look at some of these examples we've been talking about. If I select everything from a customer table and the invoice table, in this method, I'm doing a Cartesian join. I'm also not using correlation names, so it will give me an error. But it'll also give me bogus output by multiplying the columns in both tables together. I can see how many rows were returned by using the go to last page. It looks like a play pause button right out beside the down arrow for displaying number of rows per page. If I click go to last page, I can note that there are 24,308 rows. That may make the boss happy, thinking that we've made that many sales, but we know that that is not true for this database. It simply multiplied the customers by the number of invoices produced, so it attached every customer ID with every invoice. And that does not give for good output. let's expand this to an Equijoin using a where statement. So I'll put where, and I'll use a correlation name. So I'll type in the table, such as customer dot customer ID equals invoice dot customer ID. If I execute this query, I hit autocomplete and try to put the ID at the end, or maybe I mistyped. So I've got to match table name. Let me try that again. So now that I've executed a second time, I noticed that instead of 24,000 plus rows, I have 412 total. So that's much more like it. If you're an employee at the store, you would know that you only sold 412 over several years instead of 24,000 in this small music store that they have. So an Equijoin using correlation names gives better output. However, like we were saying, if you need to limit things down by maybe country, you would have to use an and or an or statement in here, and the where statement can get more complicated than need be. So this is not a recommended way to join tables together. A natural join, that is when you're basically doing the comma separated join. It creates the Cartesian output and it tries to auto link similar named columns and join the information together. So try to avoid using a natural join. I think I misspoke there. This doesn't use the comma. You actually use the keyword natural join. Let's see if it is even implemented in Postgres. So if I write a natural join and execute, it does. We get to 412. It noticed that customer ID was the same in both tables. There didn't happen to be any other columns that were similar between the two tables, and it was able to do an automatic join. And this does not work out very well. Plus, with the code, you don't know for certain what two columns are actually linked together to get the output. And Microsoft SQL, I believe, does not support natural join, which is an extremely common database system in the world. So I would avoid using this in your coding. So avoid using natural joins. Even though it works in some, it's bad coding practice and it doesn't show other users what is happening. There's also a drawback. If you have columns that are not primary foreign key columns that are the same name, it will try to auto join and match the information between two tables, and that can get you bad output. A name join is similar to the natural join, except with it, you specify the column to join on instead of it auto selecting every column between two tables with similar names. Here is an example. You select something from table 1, join table 2, and use a keyword using with the column ID that you want to link two tables together on. Again, this is not a the normal, and it's not supported in all RDBMS systems. So I would again try to avoid using this in your code. A condition join. Well, this is what we've been, sorry, I jumped forward. This is what we've been using in class. And this is the current preferred syntax that SQL coders use to join multiple tables together. So you'll have two different types of condition joins. You have an inner join and an outer join. We've mostly messed with inner joins throughout this class, and it is simply an Equijoin. So this slide here covers the inner join portion. So instead of using the where statement to link two columns together where the data equals each other, we move it into the from clause. This makes the where a whole lot easier when you're trying to limit stuff down, like you want to only see sales out of Memphis or sales out of New York. It's not cluttered with joining two columns together from multiple tables. You only have your query or your condition in your where statement. So an example, you have from table 1 join table 2, and you use the on keyword instead of using. It's a little bit more typeful because with on you specify the correlation name. Here I use the alias T1 for table 1 and the column ID equal T2 and the column ID. In this type of join, the columns don't necessarily have to be named the same. So it's more exact. Anybody reading your code can see what column in which table and the column names that they're linked across. Normally, primary and foreign key pairs, normally they are spelled identical to each other, but not always. So throughout this class, we are using the condition join type. Let's look at some examples of this before I move on. So to change this out of a natural join, I would also use abbreviations for my tables just to make the correlation names easier to type. So you select star from customer C, C being the alias. Use the keyword join by itself. That creates a standard inner join. Invoice I. And now I will type the on keyword, and I specify the primary key is equal to the foreign key. So we have we have c.customer ID. Customer ID is the primary key in the customer table. It is going to be equal to the foreign key in the invoice table. The foreign key being, again, customer ID. If I'm looking at my Postgres DB Forge Studio, I've got customer expanded out. I see customer ID has a lock on it, letting me know it is a primary key. I see customer ID in the invoice table without the lock, letting me know that it's the foreign key. Good coding practices, they were spelled the same, so I know how they are linked together. Other methods is to use a database modeling diagram. We looked up the UML diagram for the Chinook database earlier in the semester, where it showed how the columns were linked to other columns in all of the tables. So if I execute this, I will get the same output as before with the natural join. But this is the preferred way to code because anybody can look at the code, see the tables that are joined, and see easily the columns that are used in the Equijoin. other type of condition joins that we will get into are the outer join. An outer join is used to list rows that don't necessarily match between both tables. The inner join, the information has to match in both tables, otherwise information is not displayed to the user. An outer join allows for partial matching of data. You have three different types of outer joins. They are left, right, and full. Simply to create an outer join, you add left, right, or full in front of the join keyword. So as you see as this example, from table 1, left join table 2 on the primary and foreign key columns. That example would show every row from table 1, even if it did not have a matching value in table 2. It would not show you all of the rows in table 2 if they did not match to table 1. So in this example, our important information we want to see is in table 1. We want to see everything, whether or not it is associated with data in table 2. If table 2 had information that was not associated with something in table 1, we just want to ignore it. So that would be this left join. It can be reversed using right. If you used right, then it would show all of the information in table 2, whether or not it matched table 1. And it would only show information from table 1 where that it had a matching pair in table 2. So in this case, we wanted the important information from table 2 shown, but not necessarily everything from table 1. The third type is a full join. All rows in table 1 and 2, whether they match or not, will be displayed to the screen. A graphic representation of this may be easier to understand. So the outer join, we have left, full, and right. So the left join, the stuff in blue would be in table 1. And it means if it's in blue, it's going to show it to the screen. So portions of data may not be linked to table 2. So it's going to show everything in table 1, and you see where the circles overlap. That's where the data matches in table 1 and table 2. It will display it to the screen. The rest of the data in table 2 is ignored. The right join does the opposite. Everything in table 2 is shown, and only the information that matches in table 1 to table 2 is shown with the overlap. The full outer join, as you see, information in both tables are shown, whether they match in the middle here, where you see the two circles overlapping, or not. You stuff to the left or the data to the right. Notice the inner join. It only shows data that matches from both tables. So you see only the center highlighted part is blue. Now the percentage of matching here, this is just a graphical representation. You may end up with 100% match between table 1 and table 2, or partial. So this is just showing what would happen if you had partial information matching between the two columns. Let's look at an example of that. So I have 412 rows right now. This is only where customer information matches invoice. If I want to see if we have some customers that have never purchased anything, I would type a left join here. So right now we had 412 rows where we had customers matched invoices. If we happen to have a customer that's never purchased anything, we will display him and this row count could go up. It might not. Let's check and see if it exists. So when I execute, it appears we have no customers that have not been assigned an invoice. We can check if there's invoices in our system that no longer have customers. Maybe we've deleted a customer and an invoice for that deleted customer no longer exists. It may or may not be in the Chinook database, but we'll try. Again, I got 412. So it appears that everything in this database with invoice and customer has a 100% match. I'll try full. It should still be 412 because left and right gave us the same output. So we have 412. In our alternative method of instruction questions that are in Canvas, you'll notice those under week 11. I use different tables than customer and invoice, and you will get slightly different output between left, right, and full. One of them will have a different output than the other two. Two of them will likely match up together. The last portion of our chapter covers union. It's not really a true join because you're not joining tables together. You're just taking the output from one select statement and adding the results of another select statement together to form one long listing. That's also known as concatenate. So concatenate just means taking one set of information and combining it with another set of information. So if your dad made a grocery list and your mom made a grocery list and gave you a grocery list for Kroger, you could look at both lists and combine them into one. So practical uses. You may have archived data. So anything that was sold in, say, 2019 could be moved into an archived table, and then you would have a table for current year. So if you wanted to combine current year sales with last year's sales, you could select the table that contained current year and the table that contained 2019 and union those two select statements together to get a full listing of everything sold in 2019 and 2020. So we don't have an archive table within our Chinook database, but we can practice the union. One last option to union here. The way you write it, you write a select statement, use the keyword union, enter another select statement, end it with a semicolon. Note the semicolon only goes at the very end of the second select statement. By default, union eliminates duplicate rows returned between the two select statements. If you want all rows between the select statements returned, use the all keyword at the end. Going back to our grocery list that your mom and dad wrote for you. If your mom wrote down milk and your dad wrote down milk, would you get 2 gallons of milk? Or would you realize that you need to combine those and only get 1 milk? So that would be the difference between union versus union all. Let's look at an example. So maybe I want to do a left join. And I want to union that with a right join, which would be the same thing as saying full join, but we're just practicing union. Notice I took the semicolon away from the end of the first select statement. I issued the keyword union, and I'm writing another select statement. However, this time using right. So this output would be the same as full join because we're doing left and right, but I'm just showing you what would happen if you union two different select statements together. The column output also has to be the same. I couldn't select a single column here and a last name column here. I need to have the same output for it to be meaningful. And if I execute, I still get 412 rows. Great. It looked at the grocery list column and seen milk was on both of them and decided we're going to combine this into one list and only have milk once. If I do union all, and that is saying that if you see milk on your mom's grocery list, you write milk, get a gallon for her. You see milk on your dad's list, you'll write milk a second time and a gallon for him. So let's execute. And now instead of 412, I have double. I have 824. So it doesn't always double. Depending on how that you write your select statement, you may not have 100% every row overlapping the other row. It only eliminates duplicates. So if you do a union all duplicates are shown, and including unique rows are shown. So your output, depending on what your select statements are displaying, can be different. Union all is probably not something used very often, since you just want the, I would think most of the time, just the unique rows outputted between two separate tables like this. Your homework. If you log into Canvas, which you probably already have, possibly to view this video or through a link in the email, I've highlighted the week that we are in after spring break in yellow, make it easier for you to peg. So week 11, you're to read chapter 11. Also, this video. The link will be posted after I render the video and put it on YouTube. We have the PowerPoint that was just seen as this video. You can download and read for yourself. I've got the videos from week 1 and week 2 showing you how to install dbforge, download Postgres, and set up the Chinook database. The Chinook database was used as an example. I hope the week before spring break on Wednesday you copied your database like I told you and were able to take it home. If you're not allowed to set up dbforge because maybe you're using a public computer at a library, I can set you up an account that you can use a web browser and remotely see your classroom computer, which should have the dbforge Studio, the PostgreSQL database, the Chinook database already installed. If you happen to need that, I can create an account and you'll be able to log in and see your desktop. However, other classes are also remoting in LAN 1, LAN 2 virtualization or remoting in. So if you're going to access your desktop, you're limited to the time that you're normally in class. You can also attempt to access your desktop computer after hours, after 3 p.m. If you happen to need this setup, you could try to log in if another student from another class is not trying to work after hours. But preferably, you have Postgres, DBForge, and the Chinook database already at your home computer for practice. The self-test is the same as always, except for the last chapter we didn't cover it, but chapter 11, you'll answer the questions and submit them by Friday, which is April 3rd. Alternate method of instruction was this lecture video for the week, and practice questions for this chapter that we would normally do in class and work together. So I believe I've showed you enough example in this video that you can answer questions 1 through 6. Take a screenshot of the output. Notice number 5, you're actually going to use the left, right, and full joins. So you'll have 3, excuse me, on question 4, you're going to have 3 screenshots for it because you're going to use left, right, and full joins displaying the output of each. Then you'll use union and the union all, as I did an example before. All of the tables that you're using here will be over the artist table and the album table. You'll get a little bit better results. Some of the left, right, and full will be the same. An example of the output. I need the full SQL code shown on the screen, so you may have to adjust your output window smaller so I can see every line of code. And then on your output, I'm normally looking at the total number. What is your ending record? If it says 1,000 at the end, that's not your ending record. You need to hit the go to last page, the play pause button up towards the top of your output, and it will take you to the very end, just as I showed at the first few minutes of this video. You can use snipping tool or snip and sketch, I think is what they call it now, and select the screenshot. There will be a total of 8 screenshots because number 4 has 3. That adds up to a screenshot for each one of these plus 2 extra for number 4. Each screenshot is worth 5 points, so you'll get 40 total points for doing this assignment. On your own, for practice, I want you to work through the join through union at W3 schools. When you launch that, W3 schools will come up and it should have you on joins. Read through, work the self-test, run the exercise, and then go on to the next. You'll have inner join, left join, right join, full join, a self join, and union. So that's what I meant by work from join through union. So do each of the exercises and read through each one of these for practice. And that will be the end of this video. And hopefully if you have any trouble sleeping, you'll just start the video up, listen to me right before you go to bed, and you'll fall right to sleep.